5, Lesson 1, Lists, Explore. At the conclusion of this lesson, you will be able to use appropriate vocabulary to describe lists. You will be able to use an index to reference specific elements of a list. First, think about or brainstorm lists of information that you encounter on a daily basis. Why are these lists useful? Well, some of the lists might be a grocery list, might be a to-do list, might be a vocabulary list. They're all useful in their own ways. Lists help us to group things together, like information. Grocery items, they're all the things I can get from the grocery store. To-do list, they're all the things that I have to do. Okay? Vocabulary list, it's a word and a definition, or a term and a definition, but they typically all go together. They refer to some topic. Lists help us stay organized. We can also go through a list, item by item, to check off things that we have completed or things that we know. Now, today's activity is completely and totally unplugged. That means you don't need to log into code.org. Instead, you're going to need small stacks of red and yellow stickies, or just small pieces of different colored paper, one that will be text and one that will be numeric. You'll need a small stack of snack baggies, like about 4, and a gallon-size baggie, or a large bag. You'll need a pen or pencil, a dry erase marker, and tape or stapler. If you need to, pause the video while you go get these items. Now, we've already learned that variables can help us to store one piece of information. Var says it's a variable. My name is the name of the holding place, is set to Jose. So the container for the data is called my name, and the data itself is Jose. And in this case, it's text because it has the quotes. But what if we have a lot of information? Well, what are the challenges that you'd encounter if you need to store 10 or 100 or 1,000 pieces of information using variables? All of your grades in all of your classes. Think about that. It could become overwhelming. Even the days of the week, day 1, day 2, day 3. What's day 1? Well, let's see how we can use lists to help with this problem. We're going to learn how to create and access items in lists. So today, we're going to practice using a new way to store information called a list. And you're going to follow the instructions here to make a list of your own. First, you're going to get a gallon baggie connected to smaller baggies. So you've got your gallon baggie and you're connecting it to the smaller baggies. Each smaller baggie can hold one value, just like a variable. Gallon baggies are named with the same rules as a variable. There are no spaces, can't start with a number. The smaller baggies are named using numbers, or they're numbered, starting at 0. Location 0 starts, that's the very first spot in your list, location 0. That's the start. You're going to make a list like this one below that holds between 2 and 4 values. Since you're doing this by yourself, you can't share it with another group. So go ahead and just create a list. You don't even have to use necessarily the baggies, but understand, place 0, 1, 2. So on 3 small pieces of paper, make a list. Now, what do we call these things in the list? Well, the list itself is books. That's the name of my list. Then in this list, I have different elements. I have Red Wall, Hunger Games, Wrinkle in Time. Red Wall is in location 0. Hunger Games is in location 1. Wrinkle in Time is in location 2. The 0, the 1, and the 2, the location markers, are the index of each element. So the element is the actual data, The index is its location, and the name of the whole thing is books. Your list is made up of elements. Each element has its own index. Indexes start at 0 and count up. The length of the list is how many elements it contains. This list has 3 elements, and indices from 0 to 2. So the length of the list is 1 more than the last element, or the last element is the list length minus 1. Now, notice that all the baggies can be folded up and can be placed inside the big variable baggie. Sometimes we want to think about the whole list. Sometimes we want to think about individual elements. We create a list with this following command. It creates a new list and assigns it to a variable. The square brackets indicate we're making a list. Each value is separated by commas. So var, that says it's going to be a variable. My list is the name, is set to, the brackets tell me I'm going to have a list. It's going to contain pizza in the first location, 4 in the second location. This command creates a new list and assigns it to a variable. A list is indicated with square brackets. Each value in the list is separated by commas. Write out the command that creates the list you just made. So it can be var, my list is set to, and then if I look back here, I forget what I made. Nachos, pizza, and soup. Okay. So you could have something like, oops, var food list is set to nachos, put my quotes there, oops, pizza, and I'm running out of room, the other item, and your square bracket. Okay? Now, if we want to access the values in our list, we use the square brackets next to the name of our list. So we say my list sub 1. We say sub to indicate that it's the index into the list. This expression accesses the value at the index of the list. So it's going to go to my list, and then it's going to go to location 1. Notice that we also use our square brackets. Now, if we do this, what do lunch food sub 0 and lunch food sub 2 access? Well, here's our list. Lunch food sub 0 is going to access nachos. Lunch food sub 2, 0, 1, 2, is going to access soup. Lists and expressions. You can use a list in an expression. You're going to replace the list access with a copy of the value it holds. Evaluate the expression as normal. So, if we have 3 plus my numbers sub 1, we look over here, number sub 1 holds the value of 20. So I'm going to need to replace my numbers with 20. Then I'm going to add 3 plus 20 to get 23. Likewise, my numbers sub 0 plus my numbers sub 2 is going to get my numbers sub 1, replace that value, my numbers sub 2, replace that value. So sub 1 is 10, sub 2 is 25. I will add them together because they're both numbers, and I will get 35. You can practice this, okay? Just remember that a list starts at 0. Now, my list sub 1 is set to hello. This assigns the value on the right to the index, just like a variable assignment. The old value is thrown away, and replaced. So if we look here, first, this very first line, var, my numbers is set to 10, 20, 25, says that in location 0, I get 10. In location 1, I get 20. And in location 2, I get 25. Then my numbers sub 0. I'm going to replace location sub 0 with the value 5. I still have 20 and 25 in locations 1 and 2. My number sub 2 gets 30. I didn't do anything to location 0. I did not do anything to location 1. To location 2, I threw away the 25 and replaced it with 30. Now, run this program. What is in my stuff after line 4 runs? So take and create your list, and you can create it with, oops, if I had a pen there, with 20, hat, pow, 5. My stuff sub 1 is going to get cat. So here's, if we look at this places 0, 1, 2, and 3, my stuff sub 1 is going to become cat. So here's our first list. There's our second list. The next list says my stuff sub 2 gets my stuff sub 1. So my stuff sub 2 is pow, but it's going to get whatever was in 1, which was cat. So now I've got 20, cat, cat, 5. Then, so I've taken care of this line, and this line, and this line. Now my stuff sub 0 is going to get my stuff sub 3. What's in my stuff sub 3? The number 5 plus 10. 5 plus 10 is 15. This is going to get replaced with 15. Finally, this last line, my stuff sub 3. So it says, I'm going to throw this guy away. My stuff sub 0 is 15, plus my stuff sub 0 is also 15. Add those together, and I will get 30. You replace items on the right with their values, evaluate, and then put the value that it evaluates to into that location. Pause the video and try this one. You have my stuff, dog, cat, 3, 10. My stuff sub 2 minus 1 is 1. So I'm going to replace what is in location 1 with tree. Notice that this is 0, 1. So I've replaced what is in location 1 with tree. My stuff sub 2. Well, what is the value of 2? 3. And I'm going to put into my stuff sub 3 whatever is in my stuff sub 0. So dog is going to go into location 3. Changing your list. What if you want to change it around? Well, let's learn about 3 different commands that will allow you to change your list. This first one is remove item. List, comma, index. It simply removes the item in the list from the given index. And then all items to the right, simply slide it on over. So think about if you're standing in line to get food and somebody leaves the line, everybody else just moves up. That's what remove item does. So you have your my numbers list, 10, 20, 25. Then it says remove items, my numbers. So I'm going to remove something from this list at location 1, 0, 1. I'm going to remove this. When I remove the value 20, then 25 is going to move to the right. If I remove item my numbers sub 0, I'm going to remove the value of 10, and 25 is going to move to the right. Append. Append means to attach. So I'm going to give it the list and the item that I want to append, and it's just going to queue up. It's going to get at the end of the line. So var my numbers is 10, sub 0 is 10. I just put a 10 in. It's a list of one single item at location 0. Append item my numbers comma 50 means I'm going to extend this guy out, get another location, and I'm going to put 50 in it. That's what this did. Append my numbers comma 100 says I'm going to make this list longer. I'm going to get another storage location, and I'm going to put the value 100 in it. And so this is what it's going to look like when done. Insert item, list, index, item. The list I'm going to be using, the index where something's going to be inserted, and what I'm inserting. If you cut in line, you have inserted yourself. So you go into that location and everybody else has to move back one. So here we have a list that has two items, 10 and 20. I'm going to insert item into the list called nums. I'm going to insert it into location 1, and the value is 20. So location 1 is going to be right after 0. So I'm going to, in here, I'm going to squeeze in this guy, column 20, and I'm going to push everything else down 1. So notice that 20 was inserted into location 1, and 50 moved its happy self to the right. Insert item nums. This is my list. This is the location where I'm inserting it. So I'm going to insert something right here, and that value is going to be 100. So I put the 100 in, and these two values are going to hightail it to the right. Now, take a look at this, and it's worked out over here, but you know what? What you really want to do, we'll do a shade. Go like this. Okay. Let's try running this program. Now, since you're doing it by yourself, you can't compare your result with another group, but think about it. And then say, what is the length of the list at the end? Did you pause the video and try this? Okay, let's look. We made a list, and it had 20 hat and pow in it. Great. There's a list, 20 hat and pow. You're going to append to a list the value 5. So you're going to put 5 at the end. Boom, there it is. You're going to append another value. So you're going to put 10 at the end of a list. Now you're going to remove a list comma 1. This doesn't mean you're going to look for the numbers 1 in the list. It means you're going to remove whatever is in location 1. Well, 0, 1, hat is in location 1. So I'm going to remove hat, and then everybody else is going to move to the left. Insert item, a list 2, bang. I am going to have to insert in location 0, 1. So right here, I'm going to insert the string bang, and 5 and 10 will move to the right. Now I have 0, 1, 2, 3, 4. I have things in locations 0 through 4, or I have a list that is length of 5. It is one more than the last index. You can think about the last index is equal to the length, if I can spell, minus 1, or the length is equal to the last index plus 1. Okay, here's another one. Take a look at this one and run it. There we go. There's a little bit of the answer down there, but go ahead and run this on your paper and see what you get. All right, first you build your list, 2, 5, po. Now you're going to append to B list. So you're going to append to this list, B list sub 2. What's in B list sub 2? That's po. So you've got po plus ta plus B list sub 0 is 2. So you're going to have potato or potato appended to the list. So it means you're going to put the string potato at the end of the list. Now you're going to insert into this list at 2 minus 1, which is location 1. So you're going to insert right in here the string go. Then you're going to remove from B list whatever is in location 2. So 0, 1, 2. I'm going to remove that one and slide everybody else down. So now I have 2, go, po, potato. It's not easy to just look and do it. You've got to step through it one step at a time. To wrap this up, there are 2 videos. You can access these videos either from Unit 5, Lesson 1 in code.org or from Unit 5, Lesson 1 on your Canvas course. These are both introductions to lists. The first one talks about what is the length of my list, and then the second one talks about accessing items in your list. Again, I found that I can't play a video inside of a video. It just messes everything up. So you can either pause or you can just wait because the key takeaways are coming up next. Either way, you need to watch both this video and this video. The key takeaways. A list is an ordered collection of elements. It does not mean that it's in alphabetical order or numerical order, but the indices go in order. An element is an individual value in a list that is assigned a unique index. An index is a common method for referencing the elements in a list or a string using numbers. The length of the list is how many elements it contains. Lists can grow or shrink as elements are added or removed. These are dynamic lists. Lists are an example of data abstraction. They allow us to name and program with large collections of information while ignoring the low-level details of how the data is stored, organized, etc. The programs are easier to develop and maintain. And we talk about abstraction. If I want to insert something here, there are a number of things that have to happen. I have to have 74. Then if I want to insert the number 16 here, I've got to put it in, but I also have to move 53 and 22 down. This happens in storage. You don't have to worry about how this happens in memory. It just happens. When you say insert, or if you say append, you don't have to worry about how does the length of the list get updated, how does that index, none of that. You just know that it does. You use those commands and it works. That's abstraction. You're using lists without understanding the low level, what's going on behind the scenes, how the computer's actually making that happen. Now, after this lesson, we move right on into investigating lists.